at the University of Roehampton. Any Roehampton alumni in the room? Excellent. Happy memories? That's a relief. I could have gone either way, but I couldn't do it. I'm involved with CAS, involved with NACE. I was part of the panel that drew up at least the draft of the new programme of study. So blame me or thank me, depending on how you feel about that. 18 years across 4 different schools, 3 of them as primary head teacher, hence prematurely grey hair. Not quite as old as I look, although rapidly approaching that point now. We ought to start with that nice, gentle icebreaker, getting to know your neighbour sort of thing. So, an easy question to start the day with for you here. What's the curriculum for? When I say curriculum, I don't mean the national curriculum, and I certainly don't just mean the computing curriculum. I mean the planned educational provision of your school. Have a very, very quick word with your neighbour, introduce yourselves, and say what it is you're trying to do as a school. What is your planned provision aiming for? I'll give you a couple of minutes to talk to your friends. I'll come and eavesdrop on some of these. So is that everybody sorted? Everybody knows what their curriculum's for? It's a relief. Let's take 2, 3 answers from the room, please. Brave volunteers first thing this morning. Who's willing to say what their curriculum is for? Don't all rush at once. I will pick on people. I'll do the Dylan William lolly sticks thing.
To prepare the children for an unknown future.
Preparing the children for an unknown future. That's ambitious. How can you do that? Well, you've got to. Well, that's a really, really ambitious thing. Thank you. Okay, so the planned provision is about entitlement for all. Like that very much. Anybody else? Curriculum?
Giving teachers a starting point.
Giving teachers a starting point. Oh, I like that. Yes, minimum entitlement idea. The trainees at Roehampton hate it when I do this. I say, ask these really nice opening questions and then say, well, this is what you should have said. So the Education Act of 2002 gives you a couple of statutory duties in terms of what you're doing as a school. You should be promoting the spiritual, moral, cultural, mental, physical development of pupils at your school and of society. Notice, please, the wider purpose of that. It's not just about the individual children in your class. It is about a societal good there. And preparing pupils at your school for the opportunities, responsibilities, and experiences of later life. And your point about an unknown future, absolutely. Later life for a child entering reception today. Well, not today, that would be a really weird time to start reception. But next September, what is his later life going to be like? How can we prepare for all of those opportunities, responsibilities, and experiences? Well, the national curriculum, perhaps, is one way of doing that. And the new national curriculum sets another layer of aims over and above the 2002 Act. The 2002 Act has not been repealed. If you're sat there feeling ever so slightly uncomfortable, no, that's not what we're doing. It's not what we're doing as a school. You need a conversation with your head teacher tomorrow, but I'd be fairly surprised. Okay, I'd be really very surprised, in fact. The new national curriculum sets another layer on top of that. And the Secretary of State, bless him, says the national curriculum is to provide all pupils with an introduction to the essential knowledge, notice knowledge, not skills and not understanding, that they need to be educated citizens. It introduces them to the best that has been thought and said, that's Matthew Arnold, Culture and Anarchy, and helps engender an appreciation of human creativity and achievement. These are not bad things. They really aren't. And education as cultural transmission is certainly one of the things which we do as schools. We pass on the best of our generation and our forefathers' generation to the next generation. It's one of the things that education should do. But perhaps you feel that that on its own might not be enough to do that, preparing this child joining reception next September for all of the opportunities, responsibilities, and experiences of later life, by merely passing on the best that has been thought and said, by engendering an appreciation of others' creativity, perhaps we should do more than just that. But that's fine. Paragraph 3.2 says that you should be doing more than that. Paragraph 3.2, the Secretary of State assures us it's just one element in the education of every child, that there is time and space in the school day and in each week, term, year to range beyond the national curriculum specifications. I do hope you're reassured by that. I really do, okay? Do you remember the lesson plan form you had in your training days, yeah? National curriculum objective or national curriculum coverage. If it were me going out and supervising the Roehampton trainees out in school, which I don't do enough, I really don't, then I'd say to my trainees, you can leave that blank. Or you can just put in paragraph 3.2, because you're allowed to teach anything else you want as well. Those of you in free schools, academies, independent schools, you have absolute autonomy over your curriculum, subject to some minor regulatory requirements. The rest of you, yes, you have to start with the national curriculum as that minimum entitlement, but you can do anything else you want to. If there's something you're passionate about, something you're interested in, if there's something your children want to learn about, that's fine. That's allowed. So yes, we start with the computing program study as a starting point, but we can go far beyond that if you will. So how do you decide what to teach? I think William Morris got it right back in 1880, talking about what you put in your house. Don't put anything in your house unless you know that it's useful or believe that it's beautiful. And as a rule for curriculum design, I think this is a good one. Don't put anything on the curriculum unless you know they're going to find it useful, or believe in your heart of hearts that they'll find it interesting, or that it is interesting. I think this is what we kind of did with the computing program of study. You're welcome to disagree with me. You've still got to teach it, but you are welcome to disagree with me. So, does anybody remember Jim Rose, 2009, last days of the previous government, reviewing the primary curriculum? That lovely sort of bullseye diagram of those 5 children at the centre and all of those hoops out, and ICT there at the core of the curriculum as something which is essential for learning and life. This is what he, or possibly his civil servant, said about ICT capability. Give you a moment to read that. Is there anything missing from that as a definition, though, looking on 5 years later? Yeah, absolutely. I mean, you've got to do one there. Firstly, the focus is so much on becoming users of technology. This is not a bad thing. Let's not forget that in the quest towards computer science and programming. They still do have to be able to use technology. But that it's limited to that, rather than, where is the mention of creativity? Surely we were doing that under the old curriculum. Surely we've been doing that in 2 years of disapplication. How come Jim Rose didn't recognize how central to so much primary ICT creativity is? This is the change, though. If you take one thing away from this session, this is the bit. This is the first sentence in the new program study: a high-quality computing education equips pupils to use computational thinking and creativity to understand and change the world. This is not about learning to code. It's far more ambitious than that. This is about understanding the world. This is about changing the world. This is why it deserves its place on the curriculum, because this is about understanding how the world around us works, and about being able to express yourself using this as a medium. Yeah? This is at the absolute heart. Now, creativity you know about, okay? But computational thinking is a relatively new idea. And it's worth just spending a little bit of time looking through that. Over on the left-hand side of the screen there, the left-hand side of the brain, if you will, we've got a cluster of concepts that this phrase computational thinking seems to capture. The computers are at their heart deterministic machines. They will do things exactly as you tell them to. If you set them up the same way, if you give them the same instructions and the same input, they will produce the same output. They behave in an entirely deterministic way, unless I guess you're running Windows 8. That we have this idea of breaking things down into steps, of thinking about the instructions, the rules, in order to get something done. And yes, looking for a better set of instructions, set of steps, set of ways of getting something done. That's not just when it comes to computer programming. That's across so many fields of human activity. That we start with problems and we break, or systems, and break them down into their component parts. As you said earlier, it's about conquering complexity. I fondly remember a former colleague of mine doing the assembly on how to eat an elephant. Anybody, how do you eat an elephant? One bite at a time, thank you very much, absolutely. You take a big problem and break it down into smaller parts. And then this absolutely crucial idea of abstraction, which is the real recipe for conquering complexity, about focusing on the stuff that matters and letting the other unimportant detail be something somebody else gets to worry about, or we don't focus on whilst we're dealing with the absolute essentials of a system, of a problem. You know, it's throwing away some bits of the complexity so we can deal with the big picture stuff. And yeah, this notion that, you know, present company accepted a good computer scientist is a lazy computer scientist. That's not to say every lazy computer scientist is a good computer scientist, but we look for a simpler way of doing things, or we look for a more efficient way of doing things, or we try and use the same solution to multiple problems. We look for the patterns, we try to generalize an approach to conquering particular problems to a wider class of problems. You'll see this in so many aspects of school life. If I had longer, we'd talk about those now. But the things on the right-hand side of the screen, the right-hand side of the brain, if you will, are also jolly important. How do you go about learning this stuff? Well, you start, sometimes, I did, by tinkering with stuff other people had made. And I see tinkering in a really positive fashion there, of having a look at something. Scratch scripts are brilliant for this. The whole open source nature of the Scratch community. Look at somebody else's program, tweak it, change it, remix it, make it your own. That it is at its heart a creative discipline. Since my promotion to PL at Roehampton, I apparently have taken responsibility for art and design, for design and technology, and for music, alongside computing, which is great fun. We've got people to deal with those things. But it is, you know, the fact that they've put all four of those subjects together. I think, you know, at least somebody in our executive team has made a really good decision there, because they are all creative disciplines in which you make something. And we learn so much through making things to show to others. Patrick's great insight. That yes, your programs won't work. The way you solve a problem won't work, and so you test it, so you fix it. And coding is the new gaming. It's really frustrating at times when it's not working. And so you have to persevere, you have to be tenacious. Who here learned a musical instrument as they were growing up? Keep those hands up if you're still playing. Oh, that's a shame, it really is. But why did your parents put you through that process, or why did you choose to go through that process? Perhaps to become a professional musician, but perhaps because actually through sticking at that instrument, through all of those grades and all of those lessons, it teaches you about perseverance and it makes you a more tenacious person. Coding will do much the same. And it's not an individual activity, particularly since, I suppose, the birth of the internet, that the opportunities to collaborate, to sit down and program as part of a team, pair programming is such a brilliant development methodology. All of these things. You know, is there anything on this list that you would not like to see a little more of inside your classroom? Okay, that's kind of a rhetorical question, but I will hear objections. Okay, in which case, hopefully, tackling computing and tackling it with these sorts of ideas underpinning a lot of your planning is going to bring some more of this into your classroom, fingers crossed. Who are the early years experts in the room? Okay, that's fine. You are very welcome here. You really are very welcome. There should be more of you. Okay, I work at Frobel College at Roehampton University, which is named after Friedrich Frobel, who invented the kindergarten. How's that for a CV? Okay, but he also invented this sequence of gifts, the presents that you give to a small child in the earliest stages of his or her development, including this. I think this is gift 4 or 5 in the sequence, the rectangular building blocks. Why do we still put building blocks like that into the hands of a small child, preschool child, typically? This isn't a rhetorical question. Okay. Where are the early years experts? You pick a hand. Creativity, expressing your own ideas. Absolutely. Any other reasons? Problem solving. I want to make this, And it keeps falling over. How am I going to solve that problem? Really good answer, thank you. Any other answers? Imagination, expressing yourself, thinking of something, and then making it real. That's what computing does too. Any other reasons? Collaboration. Oh, in a good early years setting, absolutely. Not always, no. But yes, anything else? Resilience, it keeps falling over. I'm going to persevere with this. Lovely. Anything else? Who said that? Spot on. Do you want to go a bit more detail around that? It's fine. I thought you meant something else by that, but yes. Okay, no. It's a really good answer. Thank you. No need to apologize for good answers. We like good answers. Okay. Froebel, and I think Piaget after him, would have argued that by playing with things like this, a young child comes to understand how the world is. You pick up the block, you let it go. We all know what will happen, yeah? It's through that direct, practical experience of the force of gravity that a young child forms a mental schema, teacher-trainer Piagetian terms, creeping in, okay, of how the world around them works. Number is conserved. Some structures are more stable than other structures, yeah? Volume is conserved. The blocks can be rearranged but not themselves changed. This teaches how the world is. It's also worth saying there are no early years practitioners I've ever met who build the model and say to the children in reception, now go and build one like that. Okay, creativity and self-expression, big part of this. Is there anybody who's sat there thinking Miles has got it wrong again? We give them these things so that they become architects when they grow up, or builders when they grow up. Good. We don't, okay? Yes, some will, but I rather think reception, indeed primary school, is a little too early for vocational training. It really is. You know, much as your country may need builders and architects, okay? Some, as I say, will. So famously, Frank Lloyd Wright went to a Froebel kindergarten. He himself acknowledged the influence of that early experience on his later work. It's plausible, isn't it? Okay. So some of the children who you teach to program a Bebot or teach to program in Kodu or Scratch will become the computer scientists and the software developers and the robotics engineers of the future. But that isn't why you teach it. You teach it because of expressing creativity and understanding the world through these sorts of tools. Okay? Anybody here teaching poetry? Only two of you. I'm worried a little. You know, what's happened to the poetry curriculum? The reason you teach poetry is not because your country needs more professional poets, but because through playing around with writing a poem, you come to express yourself and you come to understand how language works better. Ditto programming in primary school, I would say. Okay, it's worth showing you the video. It captures something of the flavour of some of what we're trying to do by getting children to write their own programs. This is from the UK version of Hour of Code. Moment of truth here, folks.
All depend on technology, and none of us know how to read and write code.
It's not this kind of geeky, techie thing. What you're doing is empowering yourself. It's a puzzle. If you like puzzles and challenges, you're going to love coding.
It's absolutely indispensable. So many of the things we're trying to do today.
Whether you want to be the Prime Minister, a vet, or a social worker, technology is going to underpin all of those jobs.
The internet is now everywhere. It's like water.
It's transformed our world in 20 years.
It shapes our countries, shapes our social dynamics. It can innovate so much, and so you have that toolkit. It means you have a lot of power to kind of come up with crazy ideas and make them real.
I got my first computer when I was in 6th grade.
I had a ZX 81 first.
I coded because I didn't just want to use the program, I wanted to start writing.
So I wrote a program to play tic-tac-toe.
You start small, building something that you're interested in, and you just learn these lessons, and there aren't that many of them, and you just eventually get to the point where you can do almost anything that you want.
You're able to launch something, created and delivered across the world in one time.
It just unlocks all these different possibilities.
If you can code, you can take the ideas in your head and make them happen.
So you can not just play Angry Birds, you can actually make your own Angry Birds. Or you can make visual effects in a film, or you can design a jet propulsion engine.
It's all about possibilities. If you want to change the world, technology is the best way.
Stakeholders are doing that. That's it.
That's it. Okay. You have there in the program of study this idea of we move from ICT to computing. In part, it's a rebranding exercise. Anybody here old enough to remember Windscale became Sellafield? Or Marathon became Snickers? Or Opal Fruit Starburst? In part, it is rebranding that ICT, through no fault of us primary teachers, mainly GCSE specifications, have become damaged goods about office skills. Did you hear the capital O creeping in there? Okay. But the change of name also moves the focus from working with information to thinking about computation. So yes, there is more of a shift in emphasis, but it also is part of that recognizing the threefold nature of the domain, that we're working with computer science, information technology, and digital literacy. In an early version of the draft, we describe those as the foundations, applications, and implications. And I find that really helpful way of thinking about what we're trying to do here. Computer science is the foundations, as the fundamental ideas, as the principles, as the science bit, if you will. But then being able to apply that to real-world problems and produce practical solutions. Being able to use software hasn't ceased to be important. So the applications of that as information technology. And then what this means for me as a person and for us as a society, a broader definition of digital literacy than the Royal Society came up with, of thinking through the implications. Let me give you an example. Take Google search. Well, I say Google search. Is there anybody in the room who doesn't use Google as their search engine of choice? Work for Microsoft? What are you using? I don't know. Any good?
Yes, fine.
Okay, Starpitch. Starpitch. Thank you for that. Okay, that's nice. Anybody else non-Google users? Okay, you as a notwithstanding, the rest of us. That's a sobering thought, isn't it? You know, never since the Reformation has one organization controlled quite so many people's access to information as Google do now. I'm not worried by that. I think they do really, really good things. But if they were to use their powers for evil, we'd all have to watch out. Anyhow, so taking Google search as an example, how Google works, how come it can give me that brilliant top of the first page result, absolutely spot on, almost all of the time? When was the last time you turned to page 2 of Google and had to look further down in order to find what you were looking for? That is amazing, it really is. And that's about computer science, and you can teach that to primary school pupils. No, really you can. Being able to use Google well is something you should teach children. Don't just assume they will pick it up. Being able to choose, yes, that's the right result, that's a helpful result. Being able to use the time filtering and the regional filtering and the reading level filtering, jolly useful things to be able to do. But then thinking through, well, what does Google now know about me? And what is Google using that information for? And the fact that we all rely on Google so much, that's moving into a more critical digital literacy territory, and it is well worth getting your children to think about those questions too. What's Google's business model? How come they can do all of this for all of us for free? Largely the same reason as farmers don't charge pigs for food. Okay, what I'm going to do now is move into the Key Stage 1 program of study. But if there's anything arising after that first 20 minutes or so that you want to get off your chest now, then do say. All right, we'll move on in that case. Key Stage 1. Who are the Key Stage 1 teachers? Brilliant, lovely to see you all. Okay, and of course, we throw you a curveball right out of the gate here, sorry, mixed metaphors, and we say that children should be taught to understand what algorithms are. Okay, who here has been teaching instructional writing in Key Stage 1? Okay, you've been teaching algorithms. Anybody got a good definition of algorithm? Okay. Yes, thank you.
Any list of instructions that achieve a goal.
List of instructions to achieve a goal. Absolutely comfortable with that. Set of instructions, or a sequence of instructions, a set of rules to get something done to achieve a goal. We will think about that as an algorithm. You have been teaching it already. If you've been doing cooking, they call them recipes over there. A sequence of instructions to achieve a particular goal. Yeah? If you've been telling children how to get ready for lunch in your classroom, you're likely to have a set of instructions, sequence of instructions to achieve a particular goal. It's something you've been teaching. Just because we're calling it algorithm, it shouldn't make it any more scary. There's a proper English word for it. Do start using the proper English word when you're talking about sets of instructions. How do you solve a maths problem? You have a set of steps that you follow there. We had a number of people responding to the consultation saying you can't possibly expect primary school teachers to use words like algorithm. Typically not primary school teachers themselves, typically advisor consultant type people, you know. But you are a generation of teachers who are using language like split val digraph to children in reception. So what's the problem with algorithm? You know, perfectly good English word for a perfectly interesting, sensible, useful idea. My friend Phil Bagg, who's running a conference very much like this down at University of Southampton today, has the classic example of the cookery thing, the recipe. Yeah? So what is your algorithm, your set of instructions for making a jam sandwich? We might have a chance to do this practically later. If we had the kit out here, we could do it now. We'd need the time as well, I suppose. So, you know, think about how would you write the instructions for a jam sandwich. And then, of course, Phil takes on persona of SandwichBot 2000 and acts out the instructions his pupils give him. We'll see a little clip of this now, maybe.
Scoop butter.
It's the voice.
Bread it, cornbread. Right hand, pick up bread slice. Lower down, drop. Lower down. You want a robot to lower himself down and drop on floor?
You get the idea, and of course we have a go at this at Roehampton, and I take on persona of SandwichBot and act out the instructions. The idea is you follow the instructions explicitly, as a computer would. Yes, there's no room for interpretation on there. So what do when the trainee says to you, spread jam on bottom? Well, stop filming is my advice. Okay. So you have that idea of algorithm. But we don't stop at that. We want to implement that as a program on a digital device. For me, this notion of programming is a two-step process. The first is solving the problem. The first is coming up with your way of how do you get this done, the algorithm, the sequence of instructions, the set of rules to get this done. Stage two is implementing that as code on the particular device in the particular language that you have in front of you. Anybody with a background in modern languages? Okay, why is there never a modern linguist around when you need one? Okay, you have this thing about poetry translation. Writing a poem is an intensely creative process. Translating a poem into a foreign language is also an intensely creative process that demands a really good knowledge of the target language's vocabulary and syntax and grammar and all of that sort of thing. But it's a very different type of creativity. And I think there's something in the analogy around what programming is. Coming up with the idea is the poem writing thing. And then implementing that as code, you've got to know the language in which you're working. You've got to know the semantics, the syntax of that language, how that language works. And that's also great, great fun. But, you know, the computer science bit is around the algorithms, the software development, the programming phase is around the code, but the two are intensely connected in this process of programming. So, you know, think about the two steps. And typically what we're seeing in a lot of primary schools that are leading the way with this is separating out those two steps fairly explicitly and expecting children to be able to articulate or sometimes draw or sometimes write down what their algorithm is before they settle down at the computer in front of them or the device in front of them. And I deliberately say device here because we deliberately said device in the program of study. If we'd said computer in this bullet point, people would have thought of computers. Okay? By saying device, we're opening the territory to include the B-bots and the probots and the roamers and all of those lovely four turtle-like things that you almost certainly have down in early years. this, yeah? And that is quite deliberate and quite explicit. These are computers. They accept input, they store programs, they produce output. Which bit of the definition don't they meet? But there's nothing in this bullet point which requires you to use any technology more advanced than the things illustrated on the screen behind me. That said, if you've been using these with your pupils since they started in nursery, by the time they're halfway through year 2, oh no, not B-bots again. It's going to sound a bit like, oh no, not PowerPoint again, isn't it, after a while? So you might want somewhere to move on to. And of course, many of these devices have their own custom app or their on-screen programming environment. But with something like Scratch, you can very easily make your own to replicate this. So we step out of this and step into this. This is Scratch, which is a lovely open programming toolkit from MIT's Media Lab, the lifelong kindergarten group. No coincidence there. And what we have here is in Scratch 2, you can make your own blocks. So down on screen here, I've got a backwards, turn left, turn right, move forward, beep, and pause set of commands. If you scroll down, you can see what's inside those. You can see how I've knitted those together out of the formal bits, out of the Scratch programming language, but we don't need to worry about that. It's there if you're interested in tinkering with this, but we can just use these ones on screen. So here is your Bebot programming challenge. What's your algorithm for moving Bebot from where she is there to the other hoop on the screen there? How would you solve that? What are the steps? What are the rules that you're going to follow? Move forward, then what? Sorry? Move forward a few times, then turn right, then move forward a few more times. Absolutely. That's your algorithm. Now let's have a go at coding that up using these custom blocks. So you said move forward a few times. How many forward steps are we going to need? Bebot robot moves forward her own length in one step, okay? In the real world, that's about 15 centimeters. On screen, it's, I think, 63 pixels, but don't worry. 5 of them. Okay, so forward 1, 2, 3. Notice how they just click together like Lego bricks. Forward 5 of those. Then it was turn right. Very good. Okay, quarter turn right. It's interpreted. Turn right on a Bebot means turn right through 90 degrees or quarter turn. Absolutely. So I've hidden that complexity. Abstraction, again, somebody else worries about that level of detail. You can see the abstraction boundary here if you're willing to scroll down and look for it. Okay, then what? Forward. Forward 3. Okay, so could you all use logical reasoning? If you didn't bring your logical reasoning with you, then just guess as to where Bebot's going to end up when I run this program. Okay, here we go. 1, 2, 3, 4. 1, 2, 3. Never mind. At which point, of course, we give up and get on with our phonics practice. No! Okay. Let's have a go at fixing this now. Any suggestions how to debug this particular script? Get rid of one of the forwards. Anything else? And another forward from down the bottom? Okay, one from the bottom, one from the top, Carol. Okay, and let's reset Bebot to where she was and run the script. 1, 2. Are you feeling confident now? And we have a winner. Well done. Thank you very much. Okay. And of course, because we've made that transition from the floor turtle, which understands only a very, very simple set of instructions, to the screen turtle, all of the other Scratch loveliness is available to us if we want to use it. So we can have, which is totally inappropriate for B, but never mind about that. Okay, so what do you think this program's going to do? Again, if you've got logical reasoning with you, use logical, I can make this bigger. Wow. Use logical reasoning to predict the behavior of this simple program. Pop the pen down, repeat 4 times, move forward twice, and turn right. Okay, now that could be that you've watched one of the earlier versions of this, or it could be that you're using logical reasoning. I kind of need to test which for my assessment record. So somebody who said square, could you tell me why you know it's going to be a square? Good.
The same amount of size.
Good.
Turning a right angle each corner.
4-sided shape, sides the same length, right angle corner. I've kind of exhausted possibilities there. Okay, so let's just test that, see what happens, pop the pen down. Feeling confident? Just on screen still. That's really nice, okay? And we know it's a square not because it looks like a square, because you've used logical reasoning to prove to me that it must be a square, which is really quite nice. Although I could, of course, play with your minds by just putting some random numbers into the blocks here. Stop it being entirely deterministic. Let's get on with the show. So you've got all of that there, understand what algorithms are, implemented as programs on digital devices, this time running in Flash on my web browser. Previously, it might be running on the Floor Turtle. I think that transition is a really easy one for a child who's grown up around this sort of technology to make. And I'd be really interested to hear reports about how that goes. The first time they move from programming the Floor Turtle, the concrete operational, to the virtual operational up on screen. Piaget, of course, wasn't able to write about that because he was working before computers. You created a simple program, or we created it, and you debugged it. Yeah? We've covered much of that bullet point through an activity such as that. Who here has played Angry Birds? Okay, there's a few of you who don't know what we're talking about here. You must remember those reports in the newspapers a couple of years ago about all of this violence in the playground, children throwing birds at pigs. No, me neither. Okay. How do you play Angry Birds? Well, you use logical reasoning to predict the behavior of a simple program. This time it's not a program I've written, although, of course, Ian Livingston on the video saying, children should be able to write something like this themselves, okay? But in order to play this and play this well, you've got to predict what will happen when the bird hits the structures in which the pigs are hiding. And through playing this, you learn about the world around you. You learn about, what happens when you throw birds at pigs, or, how objects move under gravity, more importantly. Yeah? And if you want an excuse for game-based learning down in Key Stage 1, there it is on the program of study. Yeah? It's nice if they're making the predictions about their own programs, but it doesn't say only programs that they have written in there. Everything you were doing, you're more than welcome to carry on doing. Yes, you've got to find time to fit in all of this computational thinking bit that we're adding on there, but all of the stuff you were doing, which involved using technology purposefully to create, organize, store, manipulate, and retrieve digital content, please carry on doing the best of that. Yeah? If you've got the Too Simple suite, it's still just as relevant to the new curriculum as it was to the old curriculum. We have not got rid of the information technology elements. They're still part of the statutory requirements. Okay. These slides are online if you don't want to take photographs as we're going through. Okay. And then we have this lovely thing, which used to be part of the early years requirements, about recognizing uses of IT beyond school. Switched on computing, commercial scheme of work that I've been writing over the past few months. What we've done is start with this idea. So, for instance, Unit 2.3, we are photographers. We start by thinking that children are using digital cameras themselves at home. And we want to teach them to use those better. So we talk about how to take a good photograph. We talk about how the camera works. We look at how those files can be stored on a computer, or at least we think about how those files are stored. We bring them onto the computer. We start organizing them. We delete the rubbish ones. We put stars on the good ones. And then we start manipulating that digital content by enhancing the photograph, by cropping in, by changing the color balance or the temperature settings or whatever. And so you have that sense of starting with uses of IT beyond school, bringing them into the classroom. Okay, Unit 2.1, we are astronauts. We're not relying on a huge amount of out-of-school experience there for the programming activity, but whatever. Okay, and you then have, of course, the use of the tablets, the use of the phones. Many, many children, even in Key Stage 1, are routinely using their parents' tablets or their own tablets or their parents' phones or their own phones. Anybody done the survey? Their class, how many have a smartphone? How many? 18 out of 18. That's a big number. What year group? Year 2, with 18 of them with a smartphone. Golly. Okay, that's the highest proportion I've had that low down at school so far. I was doing one of these elsewhere and was hearing about, can you believe it? Children in reception with their own BlackBerry. It's astonishing, isn't it? People still using BlackBerry. Who'd have thought of that? They're hand-me-downs. Okay. And can you believe, here we are, April 2014, and there is still no statutory requirement for you to teach children how to keep themselves safe online. I assume you've all been doing this. You've not been saying, nope, can't teach you about internet safety, not on the national curriculum, paragraph 3.2 doesn't apply in our school. Okay, of course you've been teaching it, and Ofsted would, criticize you very severely if you didn't do that. But it becomes, at last, part of the statutory requirements come next September, and about time too, most of us would say. Notice what they're expected to do, safely and respectfully. That's quite nice, actually. Keep personal information private, I'm going to return to in a moment. But where to go for help and support when they have concerns about content or contact, really, really important points. Where are the obvious two places for them to go for help and support? Parents and teachers, absolutely. It is worth having a third place, it really is. And CEOP won't do as your third place because CEOP have this, we're not interested in under sevens. They just send you back and say, go and talk to your parents, go and talk to your teachers about it. Childline won't do that. And so in your computer lab, in your library, 0800 1111, make them aware of it. Don't do a big deal about it. You don't want to generate loads of false positives. But there are going to be occasions when a child is so embarrassed to tell you or their parents about something they've seen or something that's happened to them that you still want them to go to at least somewhere to talk about that and to get that as part of what happens. Keep personal information private. We know what we meant, they meant, we didn't draft this bit, about that. And it's about not putting your phone number or not putting your photos online sort of thing. But actually, if you stop and think about it, there's a huge amount going on underneath. Keep your personal information private, like using encrypted connections, so using HTTPS rather than using HTTP, thinking very carefully before accepting cookies from a site, going to a browser that defaults to no tracking cookies would be one way of doing this. Deleting your internet history, using a VPN for your connection. I'm not sure that's something we will necessarily want to teach children in year 1 and year 2, but keep your personal information private has a huge amount of scope for going into some of the really interesting territory around digital footprint, rather than just don't put your phone number online, which is an important message to be found. Okay. On then into Key Stage 2, unless any questions arising from Key Stage 1. Okay. 0800 1111 will be somebody who works at Childline who's trained and experienced in dealing with children who are going through horrible experiences. It's a charity well worth supporting. It's part of the NSPCC. Okay. They also have an online portal for this. Okay. CEOP is absolutely fine in Key Stage 2. But they have this thing on their site about if you're under 7, then go and tell a teacher about it or go and tell a parent about it, which is fine, done for the right reasons. Anything else arising from Key Stage 1? Okay, Key Stage 2, the expectation is that the programs they write have a purpose to them. It is not programming for the sake of programming, it's programming to achieve a particular goal. Those purposes need not be limited to the traditional control technology, but that is there as something which they should have some experience of whilst they're at primary school. So some experience of controlling or simulating physical systems. For us on the computing curriculum, writing Angry Birds is simulating a physical system. Of course it is. Yeah? Okay, maybe just one level of Angry Birds. You don't want to sort of put Rockio out of business here. But by, in Key Stage 1, understanding Angry Birds, being able to play Angry Birds, making those predictions, figuring out how it works. In Key Stage 2, writing your own levels for Angry Birds. Entirely reasonable expectation, I would have said. Okay. Notice also solve problems by decomposing them into smaller parts. Computational thinking there as part of the requirements. Don't feel this is the computing curriculum is the only place to do that. You want them to decompose essay problems or research projects or maths problems into smaller parts and to think about solving each of those parts. It's project management that we're teaching here in this part of the curriculum. And that's something which has wide applications across the whole of the program study. Over in the D&T, we were quite deliberate on the computing curriculum that we didn't feel schools had to go out and buy the hardware, the control kit. Over on the design and technology curriculum, they had no such qualms. In order to do the D&T curriculum, you've got to go out and buy the control kit. So I would suggest using the same thing there as here. And in fact, you can cover both bullet points with the same hardware control. Let's build a robot and control the robot type projects. The Lego kit is gorgeous, plugs straight into Scratch 1.4 and works very, very well. Other hardware kit is available. If you're feeling really geeky, go and have a look at Arduinos, go and have a look at Raspberry Pis and start doing things with wires and LEDs and real nitty-gritty geeky stuff. But you might want to try that in our after-school club before you try and do it with 30 children all at the same time. Okay, the Lego stuff is really, really nice. No, can't recommend that highly enough. If we had more time, I'd show you the video of children programming the Lego crocodile, but you can have a look at the slides later on. We then get into the programming requirements. Use sequence, selection, repetition in programs, work with variables and various forms of input and output. And let's just step out of the slide deck and have a go at this in Scratch. So let's create a new Scratch program. Who here is using Education City or Mathematics? It's quite a lot of you. Have you noticed that essentially the algorithm is the same for all of these games, or many of these games? I'm going to ask you a question. If you get it right, I'll give you some feedback. If you get it wrong, you'll get some feedback. And then we're going to keep doing that until we sort of run out of time. So stimulus, response, reward. Anybody remember Skinner and behaviorism from their teacher training days? It's exactly that, okay? Nothing wrong with this as a way of reinforcing tables knowledge, spellings, all of that, okay? Just because it's not sort of trendy social constructivism doesn't make it a bad teaching style. It really isn't. But we can make our own program to do Education City Mathematics, to do a tables test. And essentially what we have here is asking a question. So we'll start by Scratch, waiting for some input. What is 7 times 8? And wait for an answer. That answer gets stored in this rather nice little temporary variable there. And then we need to do a little bit of selection. So we have a control structure for that. If the answer's right, do one thing. If the answer's wrong, do another. So we've got to do a test here. So we've got to compare the answer with the right value. 7/8, anybody? 56, very good, okay? And wait for the answer. If the answer is right, then we need to give a reward. Say, well done. How's that for a reward? Okay, it's worth it. Okay, otherwise we're going to have to give some negative feedback. So that's going to be something simple like no. For 0.5 of a second. Okay, could you just have a look at the script on screen? I can make that with it a little bit bigger. Does that kind of make sense to you? Anybody spotting any bugs in the program? Okay, let's have a look. Test the thing. What is 7 times 8? It's 54. No. Okay. What is 7 times 8? It's 56. Yay! Well done. Do you remember me talking about patterns and generalization earlier? We've got the same thing here if we wanted to ask another question. So rather than just asking the one question test, what is 7 times 8, I could do what is, I don't know, 4 times 9, and wait for the answer. We'd have to change the answer this time to 36. Run that through. 7 8's 56. 4 9's 36. Okay, and we can carry on doing that. A little bit boring, writing the same sort of block over and over again. Why? Remember what I said about a good computer scientist being a lazy computer scientist? Let's get the computer to do these questions for us. So get rid of that second one, and let's get the computer to generate the question. Here, I'm going to need to use a couple of, we call them variables, a little bit of memory that stores a number in it in this case. Okay, it's an abstraction of this idea of a memory location. Make a variable, I'm going to call this one A. Think of it as a shoebox. I'm going to set A up at the start of the program. Let's make another one. Anybody like to predict what this one will be called? Spot on for all sprites. And let's set B to be a random. Okay, so we'll set those both up at the start there. Oops. And we've got inside Scratch, despite it being an entirely deterministic machine, the availability for it to pick a number at random. Anybody know why I'm going for 1 to 12? 12 times table now in the national curriculum. You know, by the way, why he's done that, don't you? So when he becomes Prime Minister leading a combined Tory UKIP coalition, bring back pounds, shillings and pence. You heard it here first. Okay, now what is 7 times 8 is going to be a question we need to change this time. And that's a little bit tricky to do, so I'm just going to do what is A times B? And wait for the right answer. I'm going to have to zoom out to fit all of that on the screen. Actually, we make Scratch a little smaller. And now I can zoom back in. So we've got to do a bit of typing to do. What is, and then my shoebox, my variable here, A, whatever's in there, space times space, B and then a question mark at the end. And that should create a string of text which represents my question. So what is A times B, and wait for the right answer. Have a look at the program on screen. Tell me if it's going to work properly. Okay, so the fact that I'm checking whether the answer is 56 means it will only work 2 times out of every 144. That's not good odds, is it? So what we need to do is check whether it's the right answer to whatever A times B is. So is it the answer to A times, oops, never do live demos, folks. Okay, times B. Does that look now as though it's going to work? Shall we have a go? Okay. What is 7 times 7? It's 49. Yay, well done. Okay, now we can make this a little closer to the mathematics experience by just putting in a repeating loop here. So we could have repeat, say, 5 times, do all of that, pop that there, and is this going to work now? Same question every time? Is that not what you do in your maths tests at the beginning of a lesson? What's 7 times? What's 7 times? What's 7 times? Okay, right, you're right. So you've used, I hope, logical reasoning there to debug my algorithm or program. So we actually need to set these up at the start inside the loop rather than before we get to the loop. And I'm feeling reasonably confident here. What is 8 times 10? That is 80. Okay. 11 times 1 is 10. No. And so on. So I think we've got there the rudiments of something which is clearly threatening Mathematics and Education City's business model. You can do this as a cross-phase project. Get year 4, get year 5 writing these for year 2, year 3 to play. Yeah? Also, the whole user interface design, the cat asking this question on screen, it's a little bit dull, but we can play with how to make the interface much, much more interesting once we've done the algorithm, once we've done the coding. So there's a lot more work still to do on that. I covered that in about 10 minutes. Sorry, I'm going over time here. 4 years to cover that? Okay, you've got to find something else to do. Lead up to it, move on from it. Don't just stop at that point. So it looks as though there was a hand going up, corner of my eye. No? Okay. Yeah. Intuitive is an interesting word. The child who's started programming the B-bots in nursery and reception, who's moved on to moving floor turtles around on screen, I think this is a reasonable expectation of where to get to year 3, year 4. There's evidence from the Scratch community site that children teach themselves this by looking at what others have made. But that may be a self-selecting sample. In a class of 30, you're going to want to scaffold this somehow. This is a really interesting question about how to teach this. I think starting with an example, starting with the building blocks, and then saying, what can you make using these? Scaffold the examples. Don't say, just copy this down off the board. Don't say, here are instructions on a worksheet, type these in. Look, you've learned how to program, because I don't think they have learned to program. You want to encourage the tinkering, encourage the creativity in there, I would suggest. Intuitive, I don't think it is intuitive, but it's a simple enough interface for a child to be able to figure out what they're trying to do and to get to that point. I would say, let's have a conversation later about that, because I'm conscious that there are other people who want to come and present very, very soon. In fact, pretty much now. Okay, let's just move on to a few more things to talk to you about around this. The programs that they write won't work. This is the fun of it. It really is. And so, so what you want them to do is to figure out why it's not working. The worst possible thing you can do is to fix their programs for them. Miss, it's not working. Can you debug it from me? For me? Your default answer has to be no to that. Okay? Get them to talk to the rubber duck sat on top of their computer screen. Seriously. My friend Nicholas Schofield, school down the road from us, little yellow rubber duck on every computer in her computer lab. First thing the child has to do is to tell the rubber duck what the program's supposed to do and what the program is doing. And these rubber ducks really do help. By explaining it to the rubber duck, suddenly the child comes to realize, it's not doing that. Articulating what the code should do, really important part of the process of debugging. Get them to debug one another's script. Yeah? Karen Brennan, one of the team behind Scratch, has this lovely activity where after a quarter of an hour, everybody has to swap seats. And they go and fix one another's programs at that point. I wouldn't say do it every lesson. Pair programming. You know, those of you who don't have enough computers to go around, you're in a really lucky position here. Extreme programming, agile developers work together as pairs. One uses the keyboard and the mouse, the other thinks about the ideas. Remember, algorithms plus code, and building on the work of others. I'd show you the video, but we're kind of short for time. So fixing that, the racing car game in Scratch. Notice again, sequence of instructions, use of variables, repetition, and selection. It's the same programming ideas in a slightly different context. And then you get to this. And I worry a little that this focus on coding, the focus on programming, means people just skip these next two bullet points, which are really quite demanding ones. Understand computer networks, including the internet. By the end of year 6, your pupils should understand the internet. That's a really ambitious target. Child comes up to you at break time, Miss Sir, there's selection for you again. What's the difference between the internet and the web? What do you say to them? That's fine. I like that answer. It's much better than go back to your classroom and get on with your phonics or SATs practice, I just said, okay? They're both about connections. The internet is about connecting computers together. It's the infrastructure, it's the cables, it's the switches, it's the routers, it's the Wi-Fi stuff, which makes it possible to transmit data in digital format between one device and another device using a standard common protocol. The web, Berners-Lee's genius, was to take the existing idea of hypertext, that part of a document could link to another document on the same computer. And the internet, which had been around for a good 20 years by this point, connecting computers together, and to say we can use one to help with the other. A document on one computer connecting to a document stored on another computer and bringing that to my browser via the infrastructure of the internet. I love the feedback from his manager on the proposal. This is 25 years ago. Vague but exciting how true that was, and giving that to the world for free. And then using that. Anybody doing 100-word challenge? It's a fab thing, it is. Julia Skinner, retired head teacher, every week, creative writing challenges like 5 words or a photograph or a sentence prompt, and children come in and respond to that. There's some complicated rule about how much they're allowed to write. It'll come to me, okay? And they put that on their blog, and they put a link on her website to that. And she gets like 1,000+ entries a week. And Team 100-Word Challenge comes in and gives really good, meaningful feedback to children. When I was at primary school, the only person who read my work was my teacher, even if it was put up on the board occasionally, okay? These days, a child in your class could, through their blog, through their CAS blog, reach an audience of 2.5 billion people. That's so motivating when it comes to reflecting on what you're writing. And then using search technologies effectively. We talked a lot about Google at the beginning there, but how does Google choose what to put top of that list? How does Google choose what to put top of the list? Someone tells it to, sorry. The word you put in the search gives you which pages come up. And the ordering of the pages. Absolutely. The number and quality of inbound links is the determining factor. So the site at the top in purple there has the highest number of links pointing to it, and thus that's what goes top of Google's list. Google pay attention to 200 or so signals these days, but that's the main one that they look at. It's called the PageRank algorithm. The top bit, by the way, is the advert, yeah? So ads related to. There's no money changed hands to display that advert. The Open University have bid an instant online auction to say, if somebody clicks that link, we will pay Google so much. Company annoying you? Google them, start clicking their advert. Okay? Money changes hands. If it's Google who's annoying you, that's another matter entirely, of course. Be discerning and evaluating digital content. We know this with Wikipedia. You tell your children you can't trust everything on Wikipedia because it's made up by people. Secret for you folks, the rest of the web is made up by people too. Just because I can't edit the Daily Mail's webpage doesn't mean to say everything on there is right. It is so easy to make a page that looks very authentic, but in fact isn't. This is the government's web server. I have this lovely tool from Mozilla called X-Ray Goggles, and that allows me to see the structure of the page, which is all very nice, but it also lets me edit the page. So if you're not happy with that name change from ICT to computing, Pop it back. There you go. Happier now? Okay. Anybody in the room thinking he's just hacked the government web server in front of witnesses? Of course I haven't. Okay. I've brought the page to my browser via the magic of the internet. And once it's in my browser, I can start playing around with the HTML that I've transferred. I can publish this. I can put this on another web server somewhere. The URL won't be the same. Putting it onto the government's web server would require special permission or quite a serious prison term, I suspect, okay? But, you know, the copyright thing is not an issue. Firstly, this is covered by the Open Government License. Come, I think it's July of this year, parody becomes an exception under the Copyright and Design and Patents regulations. As long as the hacks you do are funny, you've got an exemption from copyright legislation. But only funny ones will count, okay? But showing a child how easy that is to do and getting them to do that with 1 or 2 pages and fooling their parents, what a lovely activity. Yeah? But also, key safety message, how do you know it's the right web page? Just because it says Lloyd's Bank, enter your password information, is that actually Lloyd's that I'm sending that to? You had a question for me.
What was that software?
It's called X-Ray Goggles. It's available from Mozilla. You'll find it on Google. Other search engines are apparently available. Okay. And then we have all of this, you know, train wreck of drafting. I've slightly adapted the bullet point in the program study, broken it down into 3 clauses there. Select, use, combine software on a range of digital devices, including cloud-based services. Yeah. Design and create program systems and content. Programs we've covered. Systems is really ambitious. Creating systems was level 8 under the old curriculum. We've brought it down into Key Stage 2 now. Okay, it's not just the programming stuff where there's a raised ambition here. Okay? Creating systems is an ambitious thing, but also content. So all of those lovely things you've been doing, making a PowerPoint presentation, you're allowed to carry on doing that. Really, you are. Okay. Don't think just because we're teaching all of this programming stuff, we can stop teaching all of the really important user-level skills. Collect, analyze, evaluate, present data and information. Data is the new word in there. Okay, information was there in the past. Don't do the class survey. What color eyes have you got? What color hair have you got? It's boring. They can answer that question anyhow, and you're processing personal information and need to be registered with the Information Commissioner's Office. Better to do the anonymous survey of your school. What do you think about our school-level filtering? What do you think about the way we teach in computing? That would be an interesting survey question to do. Or work with some really big public data sets. Go and have a look at what children have done as part of Young Rewired State, working with big data sets out there. And then, of course, working with a range of devices. Doesn't have to be in school. You can reference the stuff which they're doing at home. And back to the e-safety statement here. Most of the problems you have in Key Stage 2, certainly top end of Key Stage 2, are not about children not being safe online. Generally, they can tell if somebody's creepy. Relatively few of your pupils, thank God, are likely to be groomed by pedophiles on the internet. Okay? Of course, you need to teach them to protect themselves from those risks. But your responsibility, I think, should go further than that. Most of the problems you have are children being beastly to one another online. Yes? Children accessing content which they jolly well shouldn't at their age, or any age. And children lying about their age to use social networks. That is unacceptable behavior. It's also probably illegal under the Computer Misuse Act. Using Facebook's computers without Facebook's permission, technically an offense. I think it unlikely Facebook will prosecute, in all honesty. But teaching children to act with integrity and kindness and generosity in an online space. This is not just an e-safety thing, and of course, this isn't just the responsibility of the computing lessons to cover these points. This is a whole school thing, but it's also part of a whole school approach to values and character and morality. That being nice, being generous, being honest is something which we should generally be doing, not just in computing lessons. Okay, I am way over time. I'm a former head teacher, as I said, so during assemblies, nobody could tell me to stop talking. I've kind of assumed much the same with presentations I've done since. I'm on the Twittery thing. There's an email address there. I don't blog very much. If you want to see the slides again, including the ones which I've had to skip, then there's a URL. Notice the capital letters, the case